The next experiment we are going to discuss is to find the resistance of an unknown Y using meter bridge. This is the experimental setup of a meter bridge. Here you can see a 1 meter long wire attached on the wooden box, and a scale is also being attached on the wooden box. One end of the meter bridge is connected to the resistance box. Here you can see the resistance box in the diagram. A resistance box does not have a positive or a negative terminal, so any of the end can be used for the connections. Both these ends on the meter bridge are interconnected. This is very important. Then another end of the meter bridge is connected to the resistance box. The same end is connected to the positive terminal of the battery, and the negative terminal of the battery is connected to the one-way key. This is a one-way key. The second terminal of the one-way key is connected to the meter bridge. Here you can see the wire whose unknown resistance we have to find. The middle point on the meter bridge is to be connected to the galvanometer, and the other end of the galvanometer is going to be connected to a wire which is going to be slided on the meter bridge. It has to be noted that any end of the galvanometer can be used for the connections, either the positive or the negative. It is just going to shift the reflections from one side to the another side, and it is not going to make much difference. So we are going to do what? We are just going to slide the wire, one end of the wire which is connected to the galvanometer, on the meter bridge, and for checking the correctness of this experimental setup, we are going to slide the wire to the extreme left and the extreme right of the meter bridge, and we have to check that the deflections should be opposite to each other. As you can see, we are just sliding it and we are noting the deflections. As you can see, in case the deflections are opposite at the both the ends, then only we can obtain a balance point or the middle point, or we can say null deflection. We are trying to obtain the null point or the balance point here by sliding the meter bridge wire. Here you cannot see the meter bridge wire being slided, but you can see the galvanometer needle which is being deflected towards the left and the right. Its left and right movements basically show us that null point will surely be there on the wire. If the deflections are not in the opposite direction, both the directions basically, then you are never going to obtain the null point. That means there is some default in the experimental setup. Also, it should be noted that we have used a battery eliminator here. You can use a cell, you can make a cell, and then you can use that cell also in place of the battery eliminator. That's not an issue. This is the null point, and now after we have obtained the null point, we are going to take the observations. The point where we have obtained the null point on the meter bridge wire, we are going to take the readings from the corner point which is connected to the positive terminal of the battery till the point we are going to obtain, we have obtained the null point. So this much distance is going to be our L1.